Okay, so first we'll begin with what is meant by remote sensing. Just a brief understanding, and then we'll move on to um, more detail. So, remote sensing, very briefly, can be defined as any method employed to study the characteristics of objects using data collected from a remote observation point. So, any information that you collect about any object without going into the field or without going to that location, that is called as remote sensing. A very basic example would be an EDM. So when you use an EDM to measure distance to a far off point, so let's say the point is on the other side of the river and you're standing on one side and you point your laser towards there and you calculate the distance without going to that actual point. So that would be a very basic example of remote sensing. Other examples would be photographic surveying. That's a topic that we'll study after this. So photogrammetry is again, um, you take a picture from the top from an elevation, and then using that photograph, you can extract a lot of information. So the benefit is that otherwise, if you're in the field and if you want to gather different measurements, different angles, you have to measure them individually. But if you have a picture of the area from the top, a vertical picture, so using that picture, you can extract a lot of information just by scale adjustment. So that is a basic example of remote sensing. So very briefly, um, it is the acquisition of physical data without touch or contact. More specifically, it is the extraction of information about the Earth and our environment from imagery obtained by various sensors carried in aircraft and satellites. So using the word sensors over here, that means it's not just limited to photographs. We have different sensors that will talk about different ways of obtaining information, and it depends on which information that we want to gather. So usually it is gathered from sensors and cameras mounted on aircrafts and satellites. So that helps you to gather information from a distance, which increases your field of view. So you could say that usually it's used for more generalized information and not localized to a specific project. इसके अंदर so we can use different sensors that we're going to talk about. So in remote sensing types, you can see that we have photogrammetry, which is remote sensing using cameras and taking photographs. And then we have non-photographic systems such as multispectral scanners, MSS, that we'll talk about, side-looking airborne radar and LiDAR. So in all of those. So you're already familiar with radar. That's again an example of remote sensing. So what radar does is that it can sense the existence of any object in the atmosphere. It's used for detecting aeroplanes. It's used for weather forecast as well, different purposes. And we all know how what is the functioning of a radar. Similarly, we have another technique which is called as LiDAR, which stands for light detection and ranging. So it sends out lasers, and by then seeing the reflectivity of those lasers, it can draw a picture. So on the bottom, on the left, you have a LiDAR image. On the right, you have a radar image, and you can see the difference, the level of precision. So it depends on what is the objective, ultimate objective of what do you want to achieve out of remote sensing. So, abhi tak what we studied is that we started off with field surveying, very basic instruments that talked about starting from measuring tape and compass, then um, the auto level, theodolite, GPS receiver. Then we came on to GPS receiver. We'll study a little about total station in the lab when you return. So all of these are field instruments. A GPS is also a field instrument because you get the coordinates of the point where you place your receiver. So जब तक receiver नहीं होगा, आप field में नहीं जाओगे, you won't be able to use a GPS. So that is again an example of field surveying. Then we have remote sensing. So remote sensing means that you don't have to go in the field. So that means it covers aerial photography. It covers satellite imagery. It covers uh, scanning using different scanners, so all of that. So usually, if you get a sense out of it, remote sensing is usually done by mounting these scanners and cameras on aircrafts and satellites. And then once you have that information, obviously you'll have to process it to extract the relevant information that you need. So the applications of remote sensing are immense, starting from localized applications to more general, broader applications to environmental applications. Just the ease of getting data out of remote sensing is so quick that it far supersedes all the other methods that we've studied, the conventional methods, and the GPS to some extent as well, depending on what is the objective. So we have coastal applications, so you can monitor shoreline changes, sediment transport. You can map coastal features. Then we have ocean applications, tracking the weather, the wave heights, tsunamis, just the general sea water level, all of those things. Then it can be used for hazard assessment to track hurricanes, earthquakes as well, erosion and flooding. So we have a few examples of flooding that later on we'll talk about. Natural resource management, it can be used to locate natural resources, to monitor their extraction. um, अभी आपने examples देखी होंगी forestry की. How do you calculate the forest cover of a country? So it's basically images, and then those image from those images, information extracted as to know care how much is the forest cover. So it's all satellite imagery. Then urban regional planning, site investigation, geological investigation. So there's just so many applications, and with time, as we go on into this lecture, you'll see that how do you extract that information that we need. Then we have urban mapping, water resource engineering, road and highway construction, and terrain mapping and analysis. So आपने GIS का topic cover किया. A lot of these remote sensing products are inputs to your GIS maps. तो अगर आप GIS map बना रहे हो for let's say natural resources, उसमें first you need an image and information that you can feed into that GIS map. तो उसके लिए inputs कहाँ से आ रही हैं? They're coming from remote sensing. आपका जो Google map है और Google Earth है, that's a very basic example of a GIS map. उसके अंदर input कहाँ से आ रही है? Google Earth is a combination of so many pictures taken by satellite revolving around the Earth. तो वो जो satellite आपको imagery दे रही है, that is remote sensing. Images stitched together in the form of a map, and then उसके अंदर आप information अगर add करते हो, so that's GIS. लेकिन जो basic inputs हैं इसमें, they're coming from remote sensing. So that is why um, these days this has grasped a lot of importance, or a lot of data of remote sensing satellites is free. I'll talk about it at the end as well. So here's an example of flood mapping. So it's a picture taken from the top, and you can see on the left, it's the image of a river during normal river levels where there's no flood. And on the right, you have the same image when there is flooding. So just by this imagery, you can see the extent of flood, what is the flood plain, which areas has it inundated, what is the extent, and later on, you can plan your relief operations, or you can plan from future flooding as well by looking at these pictures taken from remote sensing procedures. So here's some different satellites which have been sent for remote sensing missions. Some of them are dedicated to climate changes. Some of them are dedicated to taking imagery, which are then inputs for your Google Maps, Google Earth sort of products. So different satellites, different functions. So we also talked about that what should be the elevation level of remote sensing satellites and what should be the elevation level of GPS satellites. So since the remote sensing satellites are there to extract real-time information in terms of pictures, in terms of weather prediction and everything. So they have to be at a lower elevation compared to the GPS satellites, which are at much, much higher elevation. Um, कभी आप जाके search करना, if you search International Space Station, it gives you its orbit, and if you input your location, it would tell you okay, at what time you'll be able to see the orbit of International Space Station if the weather is clear. So उनकी height काफी कम होती है. आगे जाके I'll show you some pictures taken from those satellites. Pictures आपने देखी भी हुई हैं. You can see Google Street View, um, Google Earth. तो वो सारी images हैं. So you can see के how accurate they are, and also they updated on a regular basis. Update आप कैसे देख सकते हो? So for example, let's say घर पे आप कोई काम करवा रहे हो और if you check on Google Earth imagery after a few days वो उसमें you can see the progress कि यार इतना इतना इस पे काम हो गया. So these are just some information about the radius of the Earth, the orbits of the satellites, the geostationary satellites, the altitude they're at the highest level, um, and then the speed of the satellite. So how much revolutions they can do in a day even around the Earth. So you can calculate. You don't have to memorize these, but just some interesting numbers that you can see. They've also given you altitudes of different satellites, Landsat, नोवा जर्स इनके बारे में we'll talk about them at the end. और you can see कि इनका जो altitude है it's very small compared to geostationary satellites and the GPS satellites. So how does it work? There are two basic processes, active remote sensing and passive remote sensing. In passive remote sensing, the satellites respond to external stimuli. So that means there is some external energy source. So let's say there is sun. Uh, the the radiations of the sun get reflected off the Earth's surface, and those are then tracked by the satellite system. So over here, there's external energy that your satellite system is taking benefit of. So these are called as passive sensors, or this can be called as passive remote sensing. Alternatively, we have active remote sensing, which use active sensors that have their own energy source, that have their own internal stimuli. For example, EDM, for example, radar, for example, LiDARs, all of them have their own energy source. So these sensors are called as active sensors, and this process is called as active remote sensing. So these are the different steps which are involved. First, you need to have a source of energy. The source can be internal source or an external source, like we discussed. So if you talk about passive source, the most common example is electromagnetic radiation from the sun. Or if you're talking about active source, that can be electromagnetic radiation from radar. So once you have that source, what happens is that first there is, so both these sources are at an altitude. So first that electromagnetic radiation has to interact with the atmosphere. And once it does that, you also studied in GPS as well, there is loss of energy. After that, the radiations that reach the Earth, three processes can happen. And then fourth one afterwards. That radiation can be reflected, that radiation can be absorbed by the Earth's surface, and that radiation can be transmitted. So we had a picture over. Yeah. So once you have that energy coming onto the Earth's surface, it can either be reflected back, uh, shown by this line over here, or it can be absorbed by the surface, or it can be transmitted through. So हमने क्या करना है? We have some sensor at a specific altitude. So the energy that's important for us is the reflected energy. अब इसके अलावा the energy that was absorbed by the Earth's surface, for example, अगर आप sun की बात करो, so it absorbs energy and then it keeps emitting it backwards. So that energy is called as emitted energy. We can also sense that and we can also gain information out of that. But the most important or the most quick one is this reflected energy. So after these processes, once you detect that electromagnetic radiation back at your sensors, you have data transmission and processing. That data is then transferred to your control station, similar to the GPS. Then you have image processing analysis and feature classification. That depends on what was the purpose of conducting this and what information do you want to extract out of this. So, and then you can apply them for preparation of maps and other purposes. So first, let's talk about electromagnetic radiation. So for that, you've already studied the electromagnetic spectrum, and in that you have energy which has different wavelengths. Now, the human eye can only see the energy of a specific wavelength, which is called as visible energy. Uske alawa, based on the spectrum of the wavelength, you have different classifications: radio waves, microwaves, infrared, X-rays. So different uh, classifications. But since we can only see the visible light, so we can only distinguish that. But the other wavelengths have other benefits. For example, a specific wavelength is better to be transmitted through the atmosphere. Some wavelength is better. It works when you want to perform or sense or perform survey in the water. उस case में कुछ और wavelengths होंगी which would perform better. So radiations having different wavelengths travel through the atmosphere with varying degrees of success. So different wavelengths would face different loss of energy because that's the first process that they have to face. So when you emit the electromagnetic radiation from the satellite, first there is loss of energy in the atmosphere. Or different जो wavelengths हैं, they have varying degree of success. So radiation is scattered unpredictably by the particles in the atmosphere. Um, and that scattering and absorption rates vary with the radiation wavelength. And that is how you can classify here in which conditions which wavelength would work better, and that is how you can decide on which sensor to use, because different sensors send out different EMRs of different wavelengths. So these atmospheric transmission anomalies known as atmospheric windows are utilized for most common remote sensing activities. Atmosphere से कौन सी travel करती हैं? They've classified that those are visible, infrared, and microwave. So this figure is something that we talked about earlier as well. Okay, once you have energy coming from a source, be it a passive source or be it an active source, जो incident energy है, first it would face loss of energy. उसके बाद once it strikes the surface, three things can happen. One, it can be reflected back, और जो reflection होती है उसमें the reflected angle is equal to the incident angle, and that energy is then sensed by the sensor. उसके अलावा the energy can be absorbed by the surface or it can be transmitted through the surface. जब transmit करेगी, so that would be at the same angle, or it will have a difference in velocity due to loss in energy. तो जो आपकी incident energy है, that gets transformed into transmitted energy plus absorbed energy plus reflected energy. And then again, जो absorbed energy है, that is reflected back in very little quantity in the form of emitted energy that can again be sensed by the sensor. So, in addition, energy emitted from an object can be detected in the thermal IR section of the spectrum and recorded. Emitted energy can be result of previous absorption of energy, a process that creates heat, and remote sensing instruments can be designed to detect reflected and or emitted energy. लेकिन जो emitted energy है, that can have different constituents क्योंकि उसमें फिर mixture होगा from the active source and the passive source, and it takes time to emit in different volumes. के लिए you need to have different sensors which can classify the emitted energy and the reflected energy. So there's a couple of questions in the chat. First, I'll answer those and then I'll move forward. There's a question that we are studied more energy is absorbed and emitted rather than just reflected back. That's true. Um, Different surfaces have different reflective power. ये इसमें आगे जाके we'll come to that. Or you can use that feature of objects to classify between different objects. कि कौन सा object है that has usual this much reflected energy. इसकी एक ratio होती है कि how much was incident and how much is reflected back. And this is property of the surface जहाँ से वो reflect हो रहा है. So if it's concrete, उसकी एक अलग ratio होगी that will remain constant. अगर वो grassland है, अलग होगी. अगर वो roads हैं, उसकी एक अलग होगी. So that's a good question. I'll come back to that. There's a question that this point of energy emitted and reflected is not clear. So what I said was, here, once you have incident energy on the surface, some part of it is reflected and some part of it is absorbed. अब वो जो energy absorb हुई है, it has to release it with time. So that energy is called as emitted energy. That doesn't happen at that time. आहिस्ता आहिस्ता when the surface starts to cool off, तो वो जो energy absorb हुई थी, that keeps emitting it, or that's a continuous process. So usually हमारे लिए the energy that's most important in the active case and the passive case to some extent as well is the reflected energy. लेकिन जो emitted energy है, that is again a property of the surface. So वो कितनी absorb कर रहा है, उसके बाद किस ratio से उसको release कर रहा है. Using that we can again classify objects. अगर हम visible light की बात करें, um, a surface appears to be white because it reflects all of the energy. It's black because it absorbs all of the energy. ये उसकी property है जिसकी वजह से there's a difference between the reflected energy and the absorbed energy. उसकी वजह से we can classify the two colors. Similar is the principle of remote sensing sensors. कि वो जो image object classification करते हैं, it's based on the properties of the objects. क्योंकि जो incident उसके ऊपर energy आ रही है, that's the same. हम भी जो देखते हैं, the same sunlight falls on an object which is colored black and an object which is colored white. But it's the inherent property of the object that allows it to either reflect or absorb. There's a question that why Google Earth is not precise. I mean, when we see the street view of a specific point, it shows a street view of some other point which is at a considerable distance from the first point. अच्छा, उसकी जो images है ना, those images are precise. उसमें errors हैं. That is because of the incident picture, उसकी verticality. We'll discuss that in photogrammetry in detail. तो आप जो उसमें से retrieve करोगे information, that won't be that accurate. लेकिन जो आपने street view की बात की है, उसमें there's location errors और वो GPS की वजह से. क्योंकि जो images हैं, वो तो वहीं की images हैं, that's an image taken of the same location. लेकिन उसको जो बाद में connect करते हैं with the GPS coordinates, वहां पे error आता है. Okay, so moving on. Where were we? Huh. So I was talking about the reflectivity of objects. So we have over here a ratio, which is the ratio of energy of wavelength reflected from the object and energy of wavelength incident on the object. So how much was the energy that was incident on the object और उसमें से कितनी reflect हुई है? Based on that, you can classify objects. So do not think of remote sensing just in the terms of photographs या satellite images. वो उसकी एक form है. Another form is that you scan the surface of the earth or scan a particular area, उसके अंदर जितने भी ऑब्जेक्ट्स आ रहे हैं, वहाँ पे क्रॉप्स होंगी, वहाँ पे कल्टीवेटेड लैंड होगा, वहाँ पे क्ले हो सकती है, डिफरेंट फॉर्म्स ऑफ सॉइल हो सकता है, स्टोन्स हो सकते हैं, कंक्रीट हो सकता है, बिल्डिंग्स ऑफ मेसनरी हो सकती हैं. All of these objects will send out reflectivity with a different energy. और इनकी जो रेशियो है फॉर अ पर्टिकुलर ऑब्जेक्ट वो सेम रहेगी. फॉर एग्जांपल एक ब्रेक है, उसकी रिफ्लेक्टिविटी रेशियो would always remain within a very small range. So उस रेशियो को देख के, once you do these tests, once you establish a data set, you establish signature reflectivity of different objects, जो कि यहाँ पे उन्होंने बताई हुई है कि यार if you send out energy of this much wavelength, उसकी जो reflectivity आ रही होगी percentage, it would be this much. So these are signature reflectivities of different objects. So once you know that, उसके बाद किसी नए area पे जाके when you perform the remote sensing sensor को यूज करके जब आप स्कैन करोगे, so the information that you get out of that reflectivities जब आपके पास आ जाएंगी for an unknown area, you compare that with your signature reflectivities and then you can classify your objects कि which object is which one based on our established signature reflectivity data set and comparing it with a newer location, कहीं पे आपने नया स्कैन किया है वहां पे. So this is how it works. So this is image analysis. Okay, once you have that information, depending on if it's a scan, if it's a photograph, you can perform analysis on that and then you can extract the information. And the classification and feature extraction is the most important step. क्योंकि picture, अगर मैं picture photograph की बात करूं, let's say you flew a drone over your department, ऊपर से आपने pictures ले ली, then how do you extract the relevant information? उसके लिए which compensatory steps that you have to do? वो कौन से होंगे? अगर आप स्कैन कर रहे हो, उस केस में डू यू हैव दैट सिग्नेचर दैट यू कैन कंपेयर दैट स्कैन विद? तो वो सब चीजें यू हैव टू टेक केयर ऑफ दैट. उसके बाद द लास्ट स्टेप इज ग्राउंड ट्रूथिंग और एक्यूरेसी असेसमेंट के वंस यू डन इट, once you have that information on hand, then you go in the field and then you see here our photograph was telling me that this distance should be this much. Then you go in the field and then you actually measure it and see if the two match. Similarly, अगर आपने scan किया, if your scanner is telling you over here we have a small lake or a water pond, then you go in the field and you see here उसी location पे is there a water pond और वहां पे just grassy land है और कुछ और है जिसने आपको गलत classify करके दिया. So once you perform that ground truthing, you can see how accurate the whole procedure was. For example, in steps को if I take it one by one, आपको चाहिए objective was to, let's say you wanted to see, you wanted different measurements. ठीक है, आपको measurements चाहिए, जो काम आप करते हो using your theodolite, using your measuring tapes, वही काम आपको चाहिए, but instead you've opted for remote sensing in the form of photographic surveying. So you fly a drone. चलो आपके अपने एग्जाम्पल की बात कर लेते हैं, योर सर्वे फील्ड, उसका जो सर्वे का पूरा ग्रिड है, उसके ऊपर यू फ्लू अ ड्रोन, यू टुक अ पिक्चर. ठीक है. Now what you do is that once you have that picture, let's say ये पिक्चर आपके पास आई है, उस पिक्चर में these were your survey points, और let's say यहाँ पे आपका यूईटी का ऑडिटोरियम है. ठीक है. So this is on your picture. So now what you can do is कि once you have that picture printed, you just measure कि यार how much is this distance on your picture. ये आपके ऑडिटोरियम की एक साइड वॉल है, let's say. Measure it and then you go in the field and you measure it actually in the field ke how much is this distance in the field. So once you measure that, just a second. Yeah. So once you measure that, you'll get a scale for your whole photograph. उसके बाद on your photograph you can take any measurement. You can take angular measurement, you can take linear measurement, apply the scale, and then you can extract a whole lot of information out of it. And then what they say by that you should go for ground truthing, वो ये है कि then you again go in the field, take physical measurement and compare it with the measurement that was taken from the photograph again. And you can compare here how accurate the whole work was. Or on the opposite side of it, I have explained कि when you scan it, तब आप कैसे जाके ground truthing कर सकते हो. ठीक है? So these are, I'm going to end my lecture over here because the time is running out, so I'll restart it again. But abhi tak, if you have any questions, you can ask.
तो सर अगर हमने जाके ग्राउंड प्रूफिंग ही करनी है तो ये जो हम कर रहे हैं इसका मकसद फिर क्या है सर?
Sir, ground proofing is just for कह लो कि one single object. For example, आपने क्या किया है, आपने पूरे यूईटी का सर्वे करना है. ठीक है? So one way is कि आप पूरे यूईटी में जाके आपने पूरे यूईटी का लेट्स से एक मैप बनाना है. One way is कि use your Thermalite, use your auto level, use your measuring tapes. पूरी यूईटी में आप जाओगे डिफरेंट लोकेशंस पे, आपको पूरा महीना लगेगा. दूसरा तरीका ये है कि you take pictures from the top. It will take let's say 30 minutes. उसके बाद you put it in a software will stitch the pictures together, will give you a map. उसके बाद आपने बस मैप के एंड पे एक स्केल लिखना है. स्केल के लिए you have to do ground proofing. कि आप ग्राउंड में जाओ, कोई एक मेजरमेंट लो, सिर्फ एक मेजरमेंट, एंड यू कंपेयर दैट मेजरमेंट विद अ मेजरमेंट ऑन द पिक्चर. वहां से स्केल फाइंड करो. उसके बाद यू कैन टेक ऑल द मेजरमेंट्स ऑन योर पिक्चर विद इन अ फ्यू आवर्स. तो जो काम आपने महीनों में करना था वो काम आपका कुछ घंटों में हो सकता है.
तो सर ये इसकी एक्यूरेसी कितनी होती है ये जो रिमोट सेंसिंग कर रहे हैं?
यार एक्यूरेसी इज pretty good. मतलब it depends. अभी तक मैंने जो बात किया है emphasized on satellites. लेकिन अगर आप खुद से मतलब एक ड्रोन फोटोग्राफी फॉर एग्जांपल आप कर रहे हो, उसमें यू नीड टू जस्ट टेक केयर ऑफ अ कपल ऑफ थिंग्स कि जो आपका कैमरा इट हैज टू बी कंप्लीटली हॉरिजॉन्टल. वो कुछ चीजें यू टेक केयर ऑफ दैट एंड इट गिव्स यू वेरी गुड एक्यूरेसी. उसके अलावा जो बाकी चीजों के लिए रिमोट सेंसिंग यूज हो रही है, पिक्चर्स के अलावा अगर मैं स्कैनिंग की बात करूं या लाइडार की बात करूं, उसमें थोड़ा सा ऑब्वियसली डिफरेंस होगा फ्रॉम योर ग्राउंड मेजरमेंट्स. लेकिन आपको जिस एक्सटेंट पे वो दे रहा है, फॉर एग्जांपल let me show you. Yeah, can you see this picture?
Yes sir.
Over here we have a digital elevation model for a very huge area. The points colored red वो बता रहे हैं कि उनकी ज्यादा elevation है. The points in blue have the lowest elevation. So ये एक बहुत बड़े एरिया का उन्होंने digital elevation model बना दिया. Other way to do it was to take your auto level, go to so many points, take so many readings, draw the contour map manually. ठीक है? तो इस केस में you don't need very pinpoint accuracy, लेकिन इसकी accuracy बहुत अच्छी है. और even if you use the Google Earth, उस पे भी अगर आप जाओ तो it gives you contour view as well. जो आप contours खुद से बनाते हो ना,